Hi, can everyone hear me? I'm Laszlo. I'm the engineering manager of the JavaScript team here at Prezi, and I'm going to talk about the release we did a few months ago, which is the JavaScript viewer. No, 1 second. It worked 5 minutes ago.
Just a second, sorry for the delay.
There we go. Okay. So this is the JavaScript viewer. It's a really big JavaScript application. It's written in TypeScript and Hax. Both of those languages compile to JavaScript. We render the whole Prezi to canvas, and it's a really big, complicated application. 6 megabytes of JavaScript, plus the dependencies that we didn't write ourselves. There's 20 developers on the team today, and a year ago when we started this implementation, it was only 3 developers. This is the JavaScript viewer that you're looking at. So, you know, Prezi used Flash, so we had to do one big rewrite. The Flash viewer was started in 2008, and it just grew organically. It was, by the time we decided to rewrite, it was one giant ActionScript 3 code base, no modularization, everything was coupled to everything else, and it was really hard to change without introducing bugs. There was lots of state mixed in and views mixed in with models, and it made it really hard to add new features, which we're doing all the time. So we had many goals, not just one, for this rewrite. Move away from Flash, modularize, so that we could increase the number of developers on the team, and separate the model from the view, so we could correct the mistakes from the past. So we went out and we did the one thing that Joel says you should never do, is rewrite your whole product. So we had to move away from Flash. I'm not really going to explain that one. You guys know why. Then we had to modularize. So how do we prevent our application from becoming one big monolithic code base when we have more and more people working on it? So what we decided to do was create interface definitions to cleanly separate the parts of our application. They look something like this. So you have a video player, and it has some methods on it. You can play, pause, stop, and get the current time. You can seek the video, you know, exactly what you expect. This is like the interface you would have in Java or TypeScript or anything. The point is that this is in a separate file, and it doesn't even specify what language it's in. So we created this tool called Spaghetti, which is open source on GitHub, and it's a Gradle plugin that integrates with our build, and it allows you to use these interface definitions from TypeScript or Hax. And then it will compile the whole module into one JavaScript file, and only the interface will be exposed to other JavaScript files. That means you cannot inherit across these module boundaries. You cannot access the private fields because each file is obfuscated separately and the names will change. So it really prevents us from mixing our different JavaScript code and depending on the internal implementation details of some other team. So now we have this Prezi viewer. It's using 24 spaghetti modules right now. It's built together with Gradle and loaded using require.js. So each team who's working on a different module will be built differently on Jenkins, uploaded to the CDN, and then they will even be separate on the CDN. So if one team makes a change, the user's browser only has to download the new copy of that module and not the copy of the whole application. And as you saw, we have some really big modules because the whole application is 6 megabytes. So there's one there that's more than a megabyte, and you don't have to re-download it because it changes very rarely. So that's modularization. And the last goal for the rewrite was the model view separation. So the Flash viewer used the display object hierarchy. This is the API in Flash. And this was our model because we just grew the app organically and we didn't think about separation from the beginning. So this has a number of disadvantages. One is that you can't really change how your rendering works. So if Flash is slow and you want to remove the stuff that's off the screen so that it doesn't have to think about them, you can't because those objects would get removed from your model. And then if you tried to save at the same time, then they would just be lost. And it also enforces a single display for each of your objects. So if you have a picture in Prezi and you want that picture to also appear in a thumbnail, for example, here at the bottom of the screen, when you move your mouse, you see these thumbnails. So we have to have multiple copies of things on the screen. And if we have the model and view tied together, we can't do that. So mixing, this is just a general principle that everyone tells you to do, and if you don't do it from the beginning, it's really hard to do later. So we had a chance to correct that. Why did it take us so long to move to JavaScript? I mean, it's 2014, right? And the main reason is because of zooming. So because Prezi zooms, it has some very unique challenges. So if you have a browser version and an iOS version, they have to look exactly the same. The reason is because see these two arrows here? They look the same, but one is slightly shifted in one direction. So when you zoom in, even though the text aligns correctly on this one, on the second version, it's off, and then the background is white, the text is white, and then you can't see half your text, and then your presentation is messed up. So we have multiple versions of the app on multiple platforms, and we need them to all look exactly the same, even when you zoom in 100 times. And that's really hard for a number of reasons, but the biggest reason is because multi-platform text on other platforms is totally different, even in different browsers on the same computer. Here's some good examples. This is a screenshot of LibreOffice running on Linux, Windows, and Mac, and it's opening this really big Oasis specification. And if you look in the bottom, this one says 737 pages, and this one says 719 pages, and this one on Mac says 741 pages. So even though it's the same piece of software, it's running on 3 different platforms, it's totally has a totally different number of pages. And the reason is because the spacing in the text is different, so then the line wraps differently, and then the changes cascade down, and you end up with a totally different document when you print it out. This image illustrates the difference between Windows and Mac. So on Windows, they want the text to be really crisp. So they have much stronger pixel snapping. And the characters will try to fit in the pixels, which means that at different sizes, they're not exactly scaling smoothly. But whereas on Mac, they want it to look more like print. So they don't care if it's a little bit out of focus, they just want the sizes to scale smoothly and the characters to look like they would printed on a page. And this, you can understand, is totally bad for Prezi, because if you're on Windows, the line length would be totally different. It might wrap differently, or even if it didn't wrap differently, if you zoomed in on that character, put something inside the O, which all first-time Prezi users want to do, then it would be in the wrong place. And there are other corner cases that are not just about zooming, not just about the pixel snapping and the characters, but for example, in Flash, your FFI will look like this, because Flash doesn't render ligatures. And other places that can read the font file and interpret the rules correctly will render FFI as one glyph tied together. And this is much more beautiful in pieces of text. But again, if you zoom in on the dot on the I and it's not there on this version, then your presentation is going to look different. Same thing with kerning. The space, depending on how the render interprets the font file, the spacing between the letters can be different. So we had to solve this problem, and we asked a lot of people what we should do, and the best thing they could come up with actually was to render it on the server side and then send images to the client, which might work for a viewer like Google Maps. As you zoom in, it would get more tiles, but it definitely wouldn't work for an editor where the user wants to type and see their text appear on the screen immediately and still have it look exactly the same on every computer. So what we could do is write our own text rendering engine, but that would be crazy because there's so many different languages to support and so many different corner cases. So we did the next best thing. We took a rendering engine that's used by Firefox and Linux. It's called HeartBuzz, and we compiled it to JavaScript using mscriptend. And this is what we call HeartBuzz.js, and then we put it together with a font parser written in JavaScript, as well as a renderer, which we call Layout.js. And this can render text the same way on all browsers and all operating systems. And because it's written in C++, we can also compile it to native for the iPad, and you can use the same system in the native app. If you want to learn more about this, there's a presentation here that my colleague Laurent gave in Paris last year. So the way it works is we give it a Unicode string, and the rules that we parsed out of the font file are HeartBuzz.js and Layout.js, and it gives us back a bunch of lines and curves, and we render it to canvas, and then we know it will always look exactly the same. So there's another reason why zooming has unique challenges, and this is about performance. So when you're zooming in on an object, you have to manage how many pixels are on the screen. So when you're zoomed really far out, when the objects are very small, you don't want to draw a high-resolution image because it will take a really long time. In the same way, text has a lot of curves in it, so you don't want to have to draw all those little curves if the text will only be 2 pixels high on the screen. So what we do is we render these objects to different size bitmaps. This is a really common thing in games called bitmapping. So you have one tile that's like this, and then one that's half the size, and then half the size of that, all the way down. And you, depending on what size you are on the screen, you switch them. So Flash uses a display object hierarchy, where you have to add and remove children, kind of like HTML. You're probably all familiar with this. And this is how the bitmap caching worked in the Flash viewer. So when we cloak an object, that means remove all the children from it so we can take it off the screen and replace it with a bitmap. We had to get all the children and then set the children to null, and then we get another sprite and we put the children on that sprite, and then we take the graphics, clear the graphics and put it on another sprite. And then when we're uncloaking the object, we have to do the reverse. And there's a lot of add child, remove child, and setting state inside these sprites. So there's a lot of what I call bookkeeping, where you have to remember what's going on and handle the case that, oh, there's no children, or oh, there's this many children. And it's just like in your application when you get a null pointer exception. You have to always check if it's going to handle both cases. So in the JavaScript viewer, we use our own rendering engine, which is not stateful, like the Flash display object hierarchy. And this is the code in the JavaScript viewer. And it looks complicated, but what you can notice here is that a lot of calculations are done in local variables, and then a lot of stuff is pushed to the transform on the screen, and then there's a draw. But none of this stuff is persistent state. It's stuff that gets put on the screen, but the next time this method will be called, everything will be reset to the same way. So you don't have to handle the case that, oh, the children aren't there, or there's too many children there than you expected. So this is what game developers call immediate mode, where you draw to the screen, and then you clear the whole screen, and then you draw again, and things get put on the screen immediately. That's where the term comes from. So, just to recap, why didn't we use HTML and CSS or SVG to render presis in JavaScript? Well, the reason is because the font rendering differs between browsers. So, we can't rely on HTML to render our text. It will look different and it will mess up people's presentations. And we need finer grained control for performance. So, one thing we can do with our rendering engine is that when the presentation is flying, we can replace all the objects with lower resolution versions of themselves, and then when we arrive, we replace them with the high resolution. And the ones that are off screen, we don't have to draw them at all. And if we wanted to do that in HTML, then we would have to remove all those children and then put them all back. And it's a lot of work to change between the states. So the HTML and Flash's display object hierarchy, these are called retained mode APIs. They're retained because you put a child on the screen and then it stays there until you explicitly remove it. It's not like the JavaScript example I showed you where everything is reset at the end of the frame and then you draw from fresh again. And these are these APIs that you're used to, adding children, removing children, but not just about children. Adding event listeners and removing event listeners is just as tedious. You have to remember when you want to dispose of your class to remove all the event listeners, make sure there's no references to it. It's really annoying. So that's about the JavaScript viewer. Now I want to talk about React. Who here knows Facebook React? It's getting pretty popular nowadays. So it's an immediate mode rendering framework for highly interactive applications. So the example Facebook gives is this unread message bug that they had. So they have this top bar, and then they have this sidebar here, and they have this message pane. And there's three different views that are implemented in different classes, and they all show the view count. So this will show you how many messages you have unread, and it will also say the same thing on the sidebar. And when you open the message in this view, then it has to tell the other views that this message is now read, so you can now -1 from your view count. And they had this bug for more than a year, I think, where it would always say that you have one unread message at the top. And they fixed it many times and it kept coming back. And they realized it's because they're storing the count in multiple different places and they're trying to communicate, and the count gets out of sync when multiple things are happening on the page. So they invented React, where they could put the state, the count all in one place, and then re-render everything all the time and not have to do this manual bookkeeping, remember who to tell, when, and update each component separately. Same thing happened in Prezi. We had very similar experiences where you would move a group of objects and then you would undo, and sometimes the object would get duplicated. It's because you have to remember to add and remove, and sometimes your logic messes up. You have many different cases to handle than just drawing things on the screen. So the way React works is you declare what you want to draw, and then that's like your setup phase, like when you first create your DOM, but then there's no update phase. When something changes, you just do everything from the beginning again. It's very declarative, it's very natural. There's no append child, remove child, there's no add or remove event listeners. You don't have to set anything or remember that state. So you can think of it like a purely functional rendering API. You pass in, React will pass in all your properties to your render function, and then you will send back this virtual DOM and it will put it on the screen. So if it's purely functional, how do you change the state? Well, Facebook also recommends that you use this architecture called Flux, which means that you won't have cascading updates. So you don't have multiple views that are talking to each other through a controller. You don't have one update which causes another update, which causes another update. You'll have one event like a click, which will get turned into an action, which will get sent to a store, which will say update the count of how many messages are read, and then that will re-render everything. And that won't cause any updates. The only time it will come back into this loop is if there's another event from the user. This simplifies things drastically. So when we started implementing the JavaScript viewer, we weren't actually using React. But we learned a lot of the same lessons that Facebook is now talking about. One of the best articles I read this year is this one, Removing Interface Complexity. So this guy is talking about React, not directly, but he uses something similar to React to demonstrate the same principles. And he's talking about how using this immediate mode style of UI rendering is much simpler and saves you a lot of trouble. So he says in the article, we can look at React in a different light, almost as if we were operating in an immediate mode rendering, as if the divs and functions painted the screen instantly. And he's saying if you weren't using React, you would have to manually manage all these DOM nodes. So retained mode is a sucky way of doing UIs, and we'd all be better off if we were using immediate mode. And this is something that we learned because we moved away from Flash's display object hierarchy, and when we made our own renderer, we decided not to make it stateful because we ran into the same problems. Here's an example of that. This is an email from a guy on my team who is working on the rendering system, which he calls the component entity system. It's modeled after game engines that always use immediate mode, always render the next frame immediately and don't use these hierarchical retained mode APIs. So he wrote this email because he found a bug where somebody accidentally mutated a data structure. And his conclusion was that we should post the changes asynchronously, give a callback function so that at the end of the frame, once everyone's done drawing, then we'll update the state all at once. And we shouldn't do it in the middle of drawing and cause inconsistencies while we're in the middle of the draw. And this, to me, sounded exactly like Facebook Flux. So this update is actually an action with your payload information. That's the same thing that Facebook says when you get input from the user, you should turn it into an action, update your state, and then re-render everything. So this is about choosing the right abstraction for your APIs. So I've used a lot of different UI libraries. Qt, this has got a lot of praise. It's really cool if you're a C++ developer because it takes a lot of the pain away from writing UI applications in C++. HTML, Flash, they're all really powerful. Web Components is a new one that's really interesting because it's getting a lot of hype from Google. And it is really good at giving you strong abstractions like you would in Java with your classes. So you have HTML and CSS and JavaScript encapsulated into this web component, and no one else can touch it. And it's solving this one problem, but it's not really solving the fundamental problem. You still have these methods on your web component to set things, and you still have to manage the state and handle all the different cases of what state is your web component in. So they're spending a lot of effort on this and not solving this fundamental issue. So my point is that all of these APIs get it wrong. From my experience and the experience of Facebook, the right answer seems to be that we should be using immediate mode and centralized state. And this is what I want to tell you, that the UI and rendering worlds are converging on this one API that makes your life much easier. Thank you.
I think we have time for questions, so if anyone
Questions? Anyone?
I'd just like to ask that, how long did it take you exactly from cutting the first line of code to full delivery to production? Because it seems like you've been dealing with a lot of problems at the same time. Scale a team, rewriting full applications.
So we started this JavaScript implementation, I think last summer 2013. So it's about a year. But the year before that, 2012, 2013, we were working on this font rendering engine in JavaScript. And the Flash viewer actually uses the JavaScript rendering engine because there's no good C++ to Flash compiler and C++ to JavaScript compiler. So for 2 years, Prezi.com has been loading this JavaScript in the background, and then the Flash player was communicating with the external interface to render the text and then sending the information back. So even before we started implementing the viewer, we were working on the text rendering. So in that sense, it's a multi-year project.
So did you find a new class of bugs with React that you haven't experienced with the previous architecture, like React specific?
No, not yet.
I'm not an expert of React.js. I was told to ask this question. So does it make sense to use Flux with Angular.js, or did you have any experience with that?
I've never actually used Angular.js. I've read about it, and from what I know, it doesn't make sense. Angular.js is more about doing the binding automatically for you, so you don't have to send these messages through.
So what Flux does is actually...
So Angular does it automatically for you, but Angular does it in a much more complicated way. So the cool thing about React is the concept is so simple that you can just, the documentation is a few pages. There's not tons of stuff. And Flux is so even simpler that you can implement it yourself in a few hundred lines of JavaScript.
Hello. Do you do any kind of testing? And how do you test that your rendering is exactly the same in each browser?
So we have screenshot testing, but you can't actually directly compare, like say iPad to a browser, because the iPad's using OpenGL, and the anti-aliasing is totally different. So even if you try to compare directly, you need a really big threshold, and then some small differences can make their way in. So what we do is, on each platform, we take screenshots of every step in some Prezi, and then we save those screenshots as the reference. And so we have to manually compare the references between platforms, and we do discover bugs from time to time, but no, we don't have an automatic test that will compare between platforms because it doesn't really work.
how does your JavaScript implementation compare performance-wise to the native one?
It's much faster on small preses and slower on big preses. So a lot of people complain about Flash, like sucks, it uses a lot of memory, it's really slow. But if you have a really big scene that you need to render, Flash is much better at that. It's highly tuned for that kind of thing. Whereas if you have just like a small thing that you want to render, a prezi, even this isn't such a big prezi and it's really fast in JavaScript, then you pay a big startup cost for Flash. So it depends on the use case, actually.
Are there any limitations that you haven't been able to solve that you didn't have in Flash?
That's a good question. Yeah, so there are some things. For example, everybody thinks Chrome is the best browser, right? But Chrome has some funny bugs when you get up to this kind of scale. So in other browsers, if you create a lot of, I was talking about bitmap caching, right? So that means you have to create a canvas that's not on the screen and you draw into it, like a lower resolution copy of an image or like an arrow or something. And then you save that for later. And when you zoom to the right level, then you draw that onto the on-screen canvas. And so we have lots and lots of off-screen canvases, which you can think of as just memory buffers holding the pixels that aren't on the screen yet. And if you allocate lots of those, then other browsers will just consume more and more memory. And then it'll eventually start swapping and slow down. But you have to control that manually. Whereas Chrome, if you create lots and lots of canvases in the background, it will just kill them, like just get rid of them, and then there's nothing there. And then you have to go through and before you put it on the screen to check, or like read a pixel and check if the canvas is actually still there. So yeah, we run into some strange browser bugs like that. Whereas Flash is the same on every browser, we just didn't have to deal with it.
I actually did see something like that just 2 days ago in Prezi, when like zooming in. I saw something like that just a couple days in Prezi when zooming in, the background wasn't there anymore and it seemed like it had to reload.
Yeah, it could be that bug, I'm not sure.
Last question, anyone? Okay.
One question, you mentioned Canvas and why you didn't choose SVG. What about WebGL? Would you, or to rephrase it, if you would implement it today, this thing, would you use different technology to do it?
No, we would still use Canvas because it's the best way to get the same rendering on every browser. WebGL is immediate mode rendering. It's cool. It doesn't suck like the other ones, but it's not really stable enough right now. That's why we didn't choose it. Maybe later.
Thank you for your questions, and thanks again, Latika, for your presentation.